Hey,
And
hey.
hello, hello. How are you today?
I'm great. How are you doing? Devoxx looks amazing, even virtual.
Thank you. Yeah, we are so excited today that we started this conference. So I will not steal more time from your talk because we are a bit behind of the schedule. So please, the mic is yours. Please start.
Okay, thank you. So, we're going to talk about a few things today. And the first thing I'm going to talk about with you is this word that you see in your screen right now. Just wait a second till you actually see it. And the word is trust. We need to trust upon something. And I want to take you on a journey I had a couple of months ago. Basically, 18 months ago, I went on a journey to buy a new car. And I ended up with a brand new blue Volkswagen Polo. It was straight from the factory. And it looked like this. And I hope you can see my screen at this point. Super new, straight from the factory. And I bought it straight from the factory for a reason. Because I can trust it. I can trust it blindly if I go from A to B on the highway and only have to care about putting enough gasoline in the tank, and I do not have to care about if it would break down or something like that. I can trust it blindly. But say I do not have that much money to spend, or I just want that same car but 20 years older. What happens then? Like, here you've got the same type of car, 20 years old, and it can still be perfectly fine, right? But how much can I trust this car? Think about it. The person I'm selling it or I'm buying it from, is that the first owner or the second, the third, maybe the fourth? And can I trust that owner? I don't know anything about cars. So, how can I trust that this car is still worry free? How can I trust it blindly? Maybe if I knew something about the history, or it had enough service levels, or at least some parts were replaced, right? If that is okay and I have proof of that, then a 20-year-old can still be very fine and I can trust it. But as I do not know anything about cars, I have to trust the person that's checking it. Basically, I have to trust the engineers. So let's go into software development, because this type of trust is interesting. How does a software development lifecycle works? Check it out. At first, we're building something small, something like a POC or an MVP. It's a very small project, very scoped, and we can get this out. It works perfectly fine in the boundaries that it needs to be, like this little shed over here. And then your manager comes up to you and says, well, we have a change of site, and can we add this little button on the site? And it's, that's actually out of scope, but as it is still the beginning of it, it's all fine. And you add that little button on the site. Perfect. A little bit out of scope, but it fits actually. It's natural. As this goes into production, because we all know that MVPs and POCs will never just stay at MVP. If it works, they will push it to production. Great. And then your second level manager comes up to you and says, from a business perspective, we have this amazing idea. Why can't we just take this feature and combine it with the stuff that you made? And you're like, yeah, that's possible. But you have to deliver it within a week. And then you're like, oh, but actually, this thing is not built. The foundation is not okay for that. However, if I do some trickery and I do some workarounds and I do some spaghetti coding, we can do this. So with a little bit of hacking and a little bit of, well, dirty code solutions, we can make this happen. And again, it works. But you know what happens then? If you give them one finger, they will take the second one and the third one and the fourth one, and they will grab up your whole arm and your leg, and you end up with doing more of that stuff. Because, hey, we already have this, right? Why can we not build this on top of that? And you end up eventually with a very large monolithic application that does everything. It can communicate to space, it can fly helicopters, and actually, again, the foundation was not built for that. Getting back to that trust, would you trust this building? Well, I draw it, so probably not. But would you trust this building if it really exists? Would you trust it enough to live there with your family? Hold that thought. My name is Brian. I am a developer advocate for Sneak, and we do security stuff. And we create security scanning tools and we do security research. And I am a Java developer by trade for the last 15 years. And now a developer advocate. I do a bunch of stuff for the community, like the Utrecht Java user group and the virtual Java user group, which I'm leading both. And it's a lot of fun to do. So visit the virtual Jug if you want to. It's all virtual. However, let's get into a tiny little bit of your application, and we are going to talk about your dependencies. We all know this. As a Java developer, you have seen this screen, right? It is the Spring Initialzr. It is a scaffolder, and that scaffolder gives you, well, you can actually just type in which version you want. You can type in what kind of dependencies from Spring you want, and it creates that project for you. It generates a bunch of stuff for you that you can focus on your application layer, on your business layer, which is perfectly fine because, well, that's where we make the difference, right? However, at this point, everything is all brand new. And, well, I would say you can trust this. But if you look at your application in general, this is the binary that you put into production. And how much of that binary is actually the code you wrote? Not the code you generated, the code you wrote. It's probably this. The other yellow part heavily consists of frameworks, libraries, and libraries that contain libraries, and frameworks that contain other libraries, etc., etc., etc. We pull in a bunch of dependencies from other people that other people or other companies or open source maintainers wrote, and we package that in our binary. But in the end, we are responsible for that whole thing that goes into production, because if it breaks, probably your manager comes to your team. If you look at that small yellow or that small purple dot in the middle, we take good care of our own code. We do things, I believe all of you do things like code reviews or pair programming, or we have quality stuff in place that scans your code for all these marvelous things. But do you take care of that big yellow part? So the part that you didn't wrote, that you just blindly took in, if you did that. Think about it. Because in the end, an application can look marvelous, and from the top off, it has all the modern structures that you like. But if you go deep down below, then you see that almost at the bottom, there is that little tiny dependency that is maintained by a random person in Nebraska. And what do you think happens if I accidentally run over that person in Nebraska with my brand new Volkswagen Polo? Then you're probably screwed because no more updates. However, the rest of the structure depends on it. So, some numbers. Spring Service application over here. We made a demo application that contained 222 lines of code. And of course, this is a snippet, but you guessed that already. That application had 5 direct dependencies. And as we know, dependencies pull in dependencies, and this is Spring and AWS stuff, and well, you see it on the right hand side of the screen. So 5 dependencies will end up in 54 dependencies. So at more than 10 times, almost 11 times. Then, how many lines of code did my 222 lines of application with that 5 dependencies that I put into my POM file? How many lines of code did I put into production? Because I am responsible for every single one of them if something goes wrong. Take a guess. It's over 450,000, just a little bit shy of 500,000 lines of code. And how are you treating these lines of code that are not actively visible to you? Well, let's divide this in 3 steps. Step 1, 2, and 3. And we start at step 1. Step 1 is how to pick a dependency. Well, we started off with that Spring Initialzr, so we already have a bunch, but that's probably not enough for what you actually want. You probably need to pick something more, or you want something different. So how should you pick a dependency? Well, the first question you have to ask yourself, how good is this package? And that seems obvious, but is it? For instance, does it solve your problem? And does it solve your whole problem? Or is it just a package that just a tiny little bit of the problem that you want to solve? Think about it. Maybe we should look for another package that actually solves the whole problem. Do I need that package? Think about it. If you only need something that does something with strings, and you think string utils from Apache is great, but you're only using one function of that, do you need to include the whole binary of Apache Commons? Would that make sense? Because everything you put into your application is there. It's part of that library. It may not be yet loaded, but it's all available for your application to use. It's not yet loaded in heap, but it can be. So do I need it? How many contributors are there? Obvious. And is it still maintained? If it looks good on Stack Overflow, it doesn't mean it's always good for you. If it's still maintained, well, if it's dead, if it's end of life, you probably do not want something to do with it. Because if there is a problem, you need to fix it yourself and not the maintainer of that library. So getting too deeper in it, we can search all these things out, right? We can go to the Maven repository website, and for instance, I looked at the Eclipse collections. Why? Because I'm a contributor to Eclipse collections, so I love these folks. But if you look at this, and I took the screenshot earlier, you see that there are new versions every once in a while. I mean, a couple of times a year, they bring up new versions. In August, there was a new version. In July, there was a version. And in February this year. So it is actively maintained and actively released. So that means that they're working on it, which is a good thing. If you look at the GitHub repository, you can actually see how they pick this up. How many issues are there? Are there actually issues that interest your problem area? And are they picking this up? In this case, you see that the last commit was 15 hours ago. So it's still maintained. Fair point. So far, check marked. Good choice. But then, do I need all of this? Say, for instance, I'm only want to use, because I'm on Java 8, I cannot use records yet, but I want to use a tuple. And a tuple or a triple is part of Eclipse collections. Let's include Eclipse collections. Let's incorporate that jar. But this jar is 9.9 megabytes big. Do I need all of it? Does that make sense? Or not? Maybe it makes more sense to write it yourself, because then you have it specifically for your needs. Think about it. Do I need all of it? Do I need a 10 megabyte jar to solve that one problem? I want to use a tuple or a triple. So we have established for ourselves something like, okay, how do I want to pick this? And this is something you have to work out with your team. I cannot give you the straight answers because all depends on your context. But you have established your set of rules that you want to work on in step 1. Let's all go over to step 2. Once they're in, it's not done. You have to update these things. Just like that car, if you do not update your car, if you do not maintain your car, it will break down. If that car is not maintained, I told you about in the beginning, I have to care. I have to worry about if I will come from A to B. Same holds for your application. Because if you look at dependencies, we need to think of things like dependency health. But what does dependency health actually mean? Well, it means a bunch of things. For instance, again, how many regular releases are there? Is this well maintained? How many active users are there? Are there regular commits? Basically, some of the same sort as when you picked it in stage 1. But you need to do this recursively. So it's not a one-time only and get things done. No, it is something you have to keep in mind. But also, are there indirect dependencies? If I'm just updating to newer versions, it can be that it uses other indirect dependencies. So we have to keep in some sort of way, we have to keep track on that. But that is about the health. Is it released? Are issues picked up? That makes sense. But how do I find out? How do I find out if there are new versions of that application or of that dependency available? Well, for instance, in Maven, you can use this command, Maven version display of display dependency updates, and you can see if there are new versions available. Let me show you. So I have an application over here that contains a bunch of dependencies. Well, just a couple, just to show you. 1, 2, 3, 4, 5 dependencies. Right? Okay, so let's do something what I just showed you, Maven versions display dependency updates. And what you see over here, that part of the output is this. The following dependencies in dependencies have newer versions. My H2 database has a version, so all of them have updates. So you don't have to go back to that Maven Central website and look it up look it up manually. No, you can actually use your package manager to do so. And that's fun. If I can do this, I can automate this. And I can put it as part of my pipeline as a report like, hey, there are newer versions. Probably do not want to break your build on that, but it's a nice thing to have. If you automate this, it doesn't take much work afterwards, right? So this is the way you can do this in Maven. Similarly, you can do this in Gradle as well with the following command. And if you do full stack, say you do a background or a backend in Java and a front end in JavaScript, you probably are using npm. And of course, npm can do that as well. And I'm certainly that there are a bunch of other package managers that can do the same. Pick your tools that help you to tackle the problem that these updates are there. Because if you take that increment and that increment is small, it's quite easy to update. If you leave it and a new update comes up and a new update comes up and a new update comes up, the delta between your version and the newest update might be so big that you have to rework your whole application because it breaks API. I had this once when we needed to migrate from, well, let's keep it to Java, from Java 6 to Java 8. And all the other frameworks like Hibernate and Spring and needed to have an upgrade. So that means that broke my whole application. And that was a government application. So we were out for 3 months. That means we're still running, but the new versions, no features for 3 months to get everything fixed. Because you're just postponing the pain you need to take. But more importantly, even if it works and you're fine with that, are there any issues with my dependencies? If we're looking at dependencies and we're looking at, now in this case, let's follow the blue line in Maven and how many vulnerabilities were identified over the last couple of years, it is a lot. There are a bunch of vulnerabilities, no. But are you aware that you're using the version that is vulnerable or not vulnerable? And if you look at it more closely, then in the middle pillar you see Maven Central. Most of the security problems are not so much in the direct dependencies, but in the dependencies underneath. So they so-called indirect or transitive dependencies. Let me show you this. So I will show you a problem that can happen when a dependency is not up to date. Yeah, I have to look where my IntelliJ is, and it's one stream here. Let me show you an application. And this application is not very interesting because what it does, it is a Spring Boot application that shows you a grocery list. It has 5 items, and all the items consists of a few things. An ID, a name, and a cost, and some getters and setters. The interesting part is in this. This is what we call the repository. We're using Spring Data, and with Spring Data, I can extend to CRUD repository. So that means by default, I have a bunch of stuff available like find by name and find all because of naming conventions. I do not have to integrate the actual SQL for me. It will do that for me. So I do not have to write it myself. That is amazing because now I can focus on the next step. And I'm using Spring Data REST here as well. And you see the add repository REST resource that I'm using here that instantly create a REST repository from my CRUD repository. So that means I have REST endpoints right away. Let me just fire this one up and let's see what happens. In the meantime, let's pray to the demo gods. That's always a thing with live demos, that it actually works and it runs. So if I go to localhost 8080, you will see my hell browser. And my hell browser is here to show you that I can fire off actually requests to my endpoints. For instance, if I do something like this, /item/1, you will see it will return beans, which is literally the first item in my grocery list. Same holds for 2, 3, 4, and 5. What I can do as well, I can do something like this, search, find by name, and that was actually my CRUD repository stuff. It's now turned into a REST repository if I give it the parameter beer. So let's do this and you see it will find beer. Amazing. This is how it should work. Great. Let's move on. But wait a minute. Let me get into the right folder. I think it is. Let me just try this one. Yes, this is what I need. Let's just show you this one. I will just give it again and I will make it a little bit bigger. What I'm doing here is I am firing a curl request and a curl patch request with, application JSON, path JSON, fine, but with a certain body. And this is the exact body I am giving it. And as you can see, as you can figure out, this body is JSON. What happens is in this Spring application, if I do this in my body, I am, for some reason, with a curl patch request, I am allowed to utilize SPEL, the Spring expression language. And with that expression language, I can create or I can influence the objects that are there in my system. As I said, I can influence objects like getting with the getters, getting interaction with the setters, but I can also create new objects. And what I'm doing here is I'm getting a runtime. And what I'm doing there is I'm executing a command, in this case, env. And env on a Linux system or a Unix-based system gives you the environment variables of the system, correct? So I route it from an input stream to an output stream to show it to you over here. So I fire it to that item/1, which gives normally only the first item of my grocery list. Interesting. Let's try this one out. So this curl request, if I push it over, you will see that I already see a bunch of stuff, like I'm using SDKman and some weird passwords and names. So you see that I have access to all sorts of things. I can execute a command over here. The point is, if I can execute an environment variable, I can also execute makes, removes, and all that kind of stuff. And that is because I was using the wrong version of Spring Data REST. If I would update to a newer version, that would all be cool. So you should be aware of this. And what you can do with it, for instance, you can scan your application. I scan it already for you. And well, in this case, I see in my CLI, I see a bunch of problems that are already there. And it gives you things like, okay, if you move from this version to this version, you can fix it. I can also connect it to my, in this case, I'm using Sneak, of course, but I can use I connected my GitHub repository to it, and it sees already that it has some problems over here. It's the same way, only from a different part of my software development lifecycle. I'm connecting my GitHub repo. And what you see here is I have a high vulnerable arbitrary code execution, literally in Spring Data REST, what I just did. And it has a priority score of over 800. which means that that it's a mature exploit and it already has a fix, but the exploit is actually published. So these kind of things you should be aware of. And there's tooling for that. So both it can help with, are there newer versions, but also you should be aware of, are there new vulnerabilities if you decide not to upgrade. So we had this picking, we had this maintaining, and now we need to remove stuff. So we go to step 3. And when do you remove stuff? Do you remove stuff when your disk is full? Well, probably we're working in the cloud right now, and storage is cheap. So we just pump in a new hard disk. But that's not how it works, because think about it. If I am working on a car and I'm replacing a part of the engine, would I keep the old part? No, right? If I need to replace that engine because, well, it's leaking or whatever, I get rid of the old parts. And you should do that as well. Get rid of the old parts. First of all, it can get collisions, but even though if it's there and it doesn't collide, why should you keep stuff that you're not using anymore? Let's get into that. If you see this is a Maven POM file from an old project I worked on a couple of years ago. It was a monolithic application for a major bank in the Netherlands, and it had 1 trillion dependencies. This is line 977 to 1023. Great. Point is, if you look through that dependency file to that Maven file, what I found out was that it had three different flavors of a XML parser. Yes, it was a couple of years ago, and we needed to interact with I think it was some SOAP units or whatever. But it had 3 different flavors of a library, or 3 different libraries from different vendors that basically did the same thing. What probably happened was the new developer came on, inherited this part of the project, need to do something with XML, and says, I'm not familiar with these tools, or didn't even look at the Maven file, and included a new package. And once it's in, it will never get out. That is how it's supposed to, or that is how it usually works in larger companies. Again, your package manager can help you with it. If you look at Maven, you can do a dependency, you can use the dependency analyze plugin to help you with that. If you look at Maven again, and I have this application here I showed you earlier, and I do Maven dependency analyze. This should be correct. It will help you, and it will show you, it will analyze the dependencies you have, and it will give you, hey, these are unused declared dependencies. However, if you look at these closely, you see that the first one has a test scope and the second one has a provided scope. So these are not interesting for me. These are not the things that go into production, because provided means, well, it's provided, and tested means that I only need it for test purposes. This will not end up in my binary. Let me see how we're doing for time. Well, not so much. However, what I can do is what I showed you on the slide, is do a -d ignore non-compile. So what I want is only the compile dependencies, because I do not want to get interested by the test dependencies. I don't care. It is fuzz. So if I do it like this, you will find out that I have only the compile, or only the compile dependencies, like here. And you see that I am including common slang, but I'm not using it in my actual code. Of course, this can give false positives. However, by informing you like this, you can keep things clean. And if you can keep things clean, it's easier to scan, and it's easier to get rid of dependencies, and maybe even old dependencies that may or may not contain security issues. So from a security issue, from a security standpoint, it's fine. It's also fine to have a smaller jar, because, for instance, if you put it in the cloud, you pay storage by the megabyte, and you pay a lot more because it probably needs to start up, and it's a big jar, so it needs to be unzipped, etc., etc., etc. So all times, it's better to do it like this. Let your package manager help you with the features it has, like I showed you here in Maven. Of course, in Gradle there's nothing yet natively. However, there are a bunch of plugins, and I believe the Nebula plugin is one of the better ones. I see it a lot, that people are using it a lot around me. Check, this is the version 6.14. Always check for newer versions, because they might have solved already some issues that there might are. But there are plugins available that can help you with that. And again, if you're doing front-end stuff as well with npm with the dep check, so you install npm i-g dep check, which installs this dependency checker, and then you call dep check. With dep check, it will scan your dependencies in your package.json, and it will look if there are dependencies that you do not need. So both covered for backend and frontend. So let's get back to that point where we had these three things. We had pick, what should be the criteria for a dependency to get into my system? We have update. When should you update? Why should you update? And should I actually update? And then we have on the last place remove or dispose. Let's get through all of these one more time. Pick, update, and dispose. First of all, you should include a dependency only for a good reason. Because if it doesn't solve the whole problem and you put in a bunch of stuff that is there, even if you're not using it, you see that with something weird behind the scenes, it can be touched and can become a security issue. Think about that as well. So only include it for a good reason. If there are already 3 flavors of a JSON parser or an XML parser, you do not need it. Or you rewrite the other stuff, or you use the dependency that is already there. Don't include a new one. Check your dependency health, and not only at the beginning in stage 1, but also in stage 2. And if it turns out that a dependency is not maintained anymore, maybe that is your point, that is the cue that you should break it out and look for another vendor. For instance, well, we had this famous circuit breaker from Netflix 5-6 years ago, and it's now out of date. It's not end of life. Hystrix, I'm talking about. And you probably need to move to another one because it's not maintained anymore. If you don't, it is a liability, and if something goes wrong, it's up to you to find out. It's open source, so you can, but are you willing to put that time in that? Or do you want to just use it? Scan for security issues often. So that means on your local machine. Oh, that's my microphone. On your local machine, when it goes into your GitHub repository, or Git repository, I should say, every new branch, scan if there are things that bring in new issues, because we want to get better. We do not want to get worse. Of course, in your CI pipeline, but also when it's in production. When it's in production, it can be fine at this moment, but if you keep scanning over and over again, and you can use Sneak Monitor, for instance, for that, and then you get a web interface like I showed you earlier, then you are aware that if there are problems, you will get actively pinged. Like, hey, there is a security issue with this package. Maybe you should upgrade to a newer one. And that is helpful. But you should have this tooling in place in the right way so that it helps you, not harm you. But you should do that not only in the beginning, not only during development, not only in your CI pipeline, but all of them, including going to production. Update often to newer version. That's an advice. Sometimes you cannot, I understand. But if you update to newer versions as soon as possible, the delta between, so that means the fixes, it's probably our bug fixes. The changes are small. So that means it doesn't break API probably. If it's a minor version, you can, in most cases, it is trusting the semantic versioning and that the people didn't break API. But most of the time, if it breaks API, you will get a major version, and then you need to take care of it. But I know we are all good developers. We have a great testing suite in place, so that should help you already. Of course, don't blindly change the dependency and push it. Remove unused dependencies. If you don't need it, get rid of it. It's as easy as that. Clean up your desk, clean up your car, clean up your house, and clean up your dependency part in your Maven or Gradle file. Because even though it's not touched, it is still available. And if I'm able to run code, if I'm able to do an arbitrary code execution or some serialization or deserialization issues, I might be able to pull it in memory and actually do harm with it if it contains a security vulnerability. So move it. If you don't have it, it cannot harm you. And use automation to pick or to help you with that. Both like tooling like Sneak, what I just showed you, but also like there's a bunch of stuff that's already there in your Maven or Gradle or NPM packages or the package managers. If you can automate it, it doesn't take you as much time. And as you can see, most of these things are relevant for both picking, updating, and removing. The point is, going back to that car, you cannot afford to rewrite applications every year or every month or maybe even every 2 years. Sometimes you have to trust on an older application or you have to maintain an old application. Just like I'm not always allowed or not everybody is allowed, or well, probably I cannot afford to buy a new car every year. So if I want that 20-year-old car or that 20-year-old application, or well, hopefully not 20-year-old, but that old application to run, I still need to trust this as much as that brand new car I just bought straight from the factory. My users want to trust it. My users need to trust it because, well, they trust me. So be responsible. Check your stuff. Know thy neighbors. Know what you're getting into. Thank you so much. If there are any questions, I don't know what the time is at this point, but if there are any questions, feel free to ask them. You can always ping me on Twitter. It's in the bottom corner. So yeah, thank you for your attention. Thank you for watching. I appreciate it.
Thank you, Brian. Thanks a lot for supporting our event this year in this unusual online format. So, dear participants, if you have any questions to Brian, please join the Q&A Zoom room, and Brian will be glad to answer them, and maybe you will even have a discussion. So, thank you.
Definitely.
Yeah.
All right, thank you.
Thank you. Stay safe.